Welcome back, everyone. Continuing on with our global temperatures and analyzing carbon dioxide and other greenhouse emissions. We want to take a look at looking at global temperatures over time. So I have this axis variable, AX, which I'm going to take my global temperature. If you recall, let me first do an insert cells above here. And take a look at the global temp that head, just to refreshers. We had these values and these anomalies. I'm going to take the value and I'm going to plot that, and I'm going to set the X label to be year and the Y label to be the global temperatures 5-year mean in Fahrenheit. So if I do this, I can see that I am this is 1970 to 2010 right here. It shows the year, and the global temperatures 5-year mean is listed right here as far as the temperatures go. So this does show that from 1970, although there have been dips every now and then, for whatever reason, the general trend has been that the temperature is going up. Let's take a look at emissions over at the same time. So I'm going to take the global gas data frame, call the sum method, and then call the plot method on that, and I'm going to graph this. So we can see that during the same time, 1970 to 2010, the greenhouse emissions have always also been on the rise. And you can see again, there are some little dips here and there, and the dips seem to match the dips in the temperature too, which is kind of interesting. So is there a correlation? We can't show causation, but we can probably do a correlation here, which is what I am doing down here, calculate a correlation coefficient between the two. And if you're familiar with statistics and what correlations work, this makes sense to you. I'm just using these variables to do the correlation equation, if you will. I won't do a whole lot of explaining here because this does require that you understand what correlation is and how to calculate it. It's not a difficult formula. I'm just creating the top, the two coefficients, B1, B2, and then putting it in the R, which is the correlation variable, and then taking a look at R. To understand what correlation means is that it's the number between -1 and 1. Absolute wise is between 0 and 1. 0 means no correlation. 1 means perfect correlation. -1 means, negative perfect correlation. So one goes up, the other one goes down. And then anything in between is, the relevancy or how strong the correlation is. So if you have a 0.3 value, there is some correlation, but obviously it's not perhaps as high as what we have here, which is a 0.85, which is approaching 1, which indicates a very strong correlation. Now, statistically speaking, for those of you who have some statistical background, a 0.3, 0.4 correlation is actually considered quite high. So when you get to something like 0.7, 0.8, that's an amazing correlation. In situations where you get something like a 0.7, 0.8, or 0.9 correlation, in many instances, they go back and look at the data, the collection method, everything else to make sure there's no bias involved. Because there might be bias that's making the correlation be so strong. In this case, this stuff I got these from NOAA, so I don't see how there could possibly be any bias because they're coming from various sources. But it is a very high correlation. In other words, it seems to indicate that as the greenhouse emissions have been increasing since 1970, so has the global temperature. That's what it says with this very high correlation. For this next one, I'm going to be using Plotly. So I'm going to call import plotly.graphObjects as go for graph objects. And this does require that you go to Plotly's website and take a look at how you can work with creating a map. I created a scale. And I decided to split it into these 6 ranges, 0 to 0.2, 0.2 to 0.4, well, 6 values, but 5 ranges to 20%, 40%, 60%, 80%. And I assign each one a particular red, green, blue color combination. These values can go from 0 to 255. If you have all zeros, that's the absence of color, which means black. If you have all 255s, that's every color at its most intense, which gives you the pure white. And everything in between creates these various color schemes. Now I decided to go with something that was kind of purplish in ranges. Plotly requires that you create a function called mapper, and you can pass to it a value. In this case, I want to pass to it a year. And then everything that you see over here is from Plotly. So I'm going to call go, which I imported this graph objects. Call figure, and I pass to it a data, and this data is a choropleth graph type, and you pass to it the various options that Plotly requires. These are not things that I picked. These are things that are required. And you can look at the documentation. It's pretty straightforward. You can give it the locations. It could be countries in the world, etc. But I'm interested in states. I call the state gas a data frame that I created, and I fetched the state out of it. That's going to give it the state name. Then I have this z variable, which is the state gas year, but I want to convert it to an integer. The text is going to be that I want to show up is the name of the state. Location mode would be various places, like if you want to be in Europe, Asia, Africa, wherever. I want it to be USA states. The color scale is the scale that I created up here. Do you want to use auto color scale, which it scales by itself? Usually picks the reddish colors. I didn't want that, so I got rid of that and I picked my own color scale. Reverse scale, I don't want it there. Marker line color. So this is the line that goes between the various states, and I wanted that to be all white. So I picked 255 for everything. And I picked the width of 2. You can play with the width, 1, 2, 2.5, 3, etc. to pick the thickness that you wish. Color bar tick prefix. I didn't want anything, and I want to have a title that shows the million metric ton CO2 in and the year that we are dealing with. We also have to have this update layout, and in it I'm going to put in first the string that I want with a little instruction that says this is a HTML line break, because these are all HTML, by the way. It says hover over for value. And I need to have a dictionary. Again, this is from Plotly, geo, and then comma annotations. And it's a dictionary, and you pass to the various values that you want. Show frame, show coastlines. Yes, I don't want to show the United States in a frame, in a box, but I did want to show the coastlines. I did want to show the Great Lakes, and I want the lake colors. I played with some of these colors to get kind of a bluish, light bluish color. And the projection type, how it's comes across is Albers USA. There are a bunch of different projection types, which is what you see when you look at a globe. If you put it on a flat surface, of course, Greenland ends up being huge, for instance, because of the projection type. But there are different projection types that you can apply depending on how you want the Earth to appear, or various parts of the Earth to appear. One of the popular ones is Albers, and I want Albers USA in this case. Then I have these various additional, the annotations that I have from left between 0 and 1, from bottom between 0 and 1. You play with these, you get the best feel for how the graph is going to show up. Some additional ones, X reference, paper, text source is NOAA. I put that in here, and show arrow false. And then I'm just going to call this figure that I created and updated the layout. I'm going to call the show method. So that's the function. So now that I have mapper created, I can pass to it, say, the year 2010. And this is going to create this beautiful graph for you from Plotly. You can see that it says hover for value. This is the stuff that I created. This is the legend, if you will, and I can hover over these and you can see the values for each state. This is the color scale. You can see Texas is the highest emitter. Let's actually try this from 2000. And we can see in 2000, Texas was still the highest emitter, but it was clearly a different value. Let's try 2005. And we can see that Texas is still the highest emitter. These are some of the rust belts, the industrial locations, Florida, California, of course. Over here, the rural states don't emit as much, but that goes without saying because they don't have that population and they don't have necessarily all that industry there. There is my source that I put over there from NOAA. And you can play with these things about, so if I change the annotation to be 0.07 and run this, what does that do? That didn't make a whole lot of change as far as anything here, but you can play with these values and see, what works best for your graph. Now, I have this old Plotly code here and I wanted to show you that a little while back, what you see over here was not how you wrote the code. You had to write it this way. So they had a data and they had a layout, which, as you can see, is similar in values and stuff that you put in here. And then you would create this figure, say go that figure, and pass to it the have a dictionary and pass to it data and layout, and then call return pi iplot, and that's what you had to do. Well, that doesn't work anymore. Plotly changed their API, and of course this code broke. The only reason I'm leaving it here for you to see is that by the time you see this, it's possible that everything that I've done here, and you do it and it will not work. You might break. And you would have to go do what I did, which was to go back to Plotly. Okay, what changes took place? What do I need to do? How do I call their API again? How do I make it work? So for right now, this is how you set it up if you want to get, a beautiful graph like this. Now I put a little note over here that says try equirectangular. So I'm going to copy and paste this in here and shift enter and enter, and you can see that this is the equirectangular. So this is a different projection, as you can see. Clearly very difficult to work with, so I'm going to undo that. Let me do just Command Z and shift enter, enter again, and it goes back to what I had. Well, I hope you enjoyed this, and you can see that with some of these external libraries, you can do some beautiful visualization, beautiful work that makes it very, very attractive for people to work with, and make sense of a data which otherwise is a bunch of spreadsheets, which, well, what does this mean? But this makes it really, really cool. If you're enjoying these videos, please share with loved ones and friends. As always, thank you for being a great audience, and see you in the next video.